Today we are going to study about adder circuit, and we will be studying about adding of 2 qubits, and we are going to add 0 plus 0, 0 plus 1, 1 plus 0 and 1 plus 1 in this video. Before we begin, let us look at the half adder truth table. The truth table has 2 inputs A and B, and it has 2 outputs, that is the sum and a carry. This is the truth table, and the sum will be given by CX gate in Blueqat, and the carry will be given by CCX gate, which is also known as Toffoli gate in Blueqat. We will be doing the codings in Google Colab. First we need to install Blueqat. In order to do that, type !pip install Blueqat in Google Colab. Now let us do it in Google Colab. Type the code !pip install Blueqat and click on the play button to run the code, and the Blueqat will be installed after a while. Now let us take a look at the code which performs the adder circuit operation. This is the code which will perform the adder circuit operation. The CCX gate here will be the carry circuit, and the CX gate here it will show the sum circuit. Now let us add the 2 qubits, that is 0 plus 0. Type the code that is shown on the screen in Google Colab, and if you run this code, we will get the output as 0000. Now let us try to do it in Google Colab. Type the code that was shown earlier. Then click on the play button to run the code. As you can see, the output is 0000. Now let us see how we got the output as 000 and 0. From this code, we know that the inputs are 00. Now let us take a look at the carry circuit. For carry circuit, we take 3 qubits, that is qubit at 0, 1 and 3. As we know, in a CCX gate there are 2 control bits and 1 target bit, and the target bit will flip if only the 2 control bits are both 1. Now in this case, since both the control bits are 00, the target gate will not flip, therefore the carry circuit output will be 0. Now let us take a look at the sum circuit. Here we take 2 qubits, the qubits 1 and qubit 2. We know that there is a control bit and a target. In this case, since the control bit is 0, the target gate will not flip. Now we apply CX gate again to the qubit 0 and 2. Here also, since the control bit is 0, the target gate will not flip. Therefore, the sum circuit output will be 0. Therefore, when we add 0 and 0, the output will be 0000. Now let us try and add 0 and 1. Type the code that is shown in this screen in Google Colab, and if we run this code, we will get the output as 0110. Now let us try the code that was shown earlier in Google Colab. Type the code that was shown earlier in Google Colab. Then click on the play button to run the code. As we can see, the output is 0110. Now let us see how we got the output as 0110. The inputs here will make the first qubit to 1. Now let us take a look at the carry circuit. We take 3 qubits, that is 0, 1 and 3. Since both the control qubits are not 1, the target gate will not flip, therefore the carry circuit output will be 0. Let us take a look at the sum circuit. We take 2 qubits, 1 and 2, and since the control qubit is 0, the target gate will not flip. We again apply CX gate at qubits 0 and 2. In this case, since the control bit is 1, the target gate will flip from 0 to 1. Therefore, the qubit at position 2 will change from 0 to 1 and the sum circuit output will be 1. Therefore, we get the output as 0, 1, 1, 0. Now, let us add the qubits, that is 1 and 0. Type the code that is shown on the screen in Google Colab. And if you run this code, we will get the output as 1010. Now let us try this code in Google Colab. Type the code that was shown earlier in Google Colab. Then click on the play button to run the code, and as you can see, the output is 1010. Let us see how we got the output as 1010. The two inputs were 1 and 0. Then we apply X gate to the first qubit. This X gate will make the first qubit as 1. Let us see the carry circuit. We take 3 qubits, that is 0, 1 and 3. Since both the control qubits are not 1 and they are 1 and 0, the target gate will not flip. Therefore, the carry circuit output will be 0. Let us take a look at the sum circuit. We take 2 qubits at 1 and 2. Since the control gate is 0, the target gate will not flip. We again apply CX gate to the qubits 0 and 2. Since the control bit here is 1, the target gate will flip from 0 to 1. Therefore, we get the output as 1010 when we add 1 and 0. Let us add 2 qubits, that is 1 and 1. Type the code that is shown on the screen in Google Colab. Now, if you run this code, we will get the output as 1101. Now, let us try this code in Google Colab. Type the code that was shown earlier. Now, if you run this code, we will get the output as 1101. Let us see how we got that output. Here, the inputs were 1, 1. In order to get that, we applied X gate at first and second qubit, which will make the first and second qubit 1, 1. Let us take a look at the carry circuit. Here, we take 3 qubits, that is 1, 1, 0. In this case, since both the control qubits are 1, the target gate will flip from 0 to 1. Therefore, the carry circuit output will be 1. Let us look at the sum circuit. We take 2 qubits, 1 and 2. Since the control qubit is 1, the target gate will flip from 0 to 1. Now the qubit at third qubit will be 1. Now we again apply CX gate to the qubits 0 and 2. Here, since the control bit is 1, the target gate will flip from 1 to 0. Therefore, the third qubit will change to 0. Therefore, we get the output as 1101.